Hello. So in the last lecture, we were discussing about the energy losses in the damped harmonic oscillator. So in that case, we were finding the process of finding the average kinetic energy, and that was found to be 1 by t 0 to t. That was half m a naught square e raised to power minus 2 gamma t, and then three different terms were there, 1 plus 2 plus 3. So that three terms, first term was integration of 0 to t sine square omega t plus phi, and second term was that is dt. Then the second term was 0 to t cos square omega t plus phi and dt, and third term was 0 to t sine of omega t plus phi into cos of omega t plus phi. So that is dt. So all the three terms integration, we have to solve it out, because without solving this integration we cannot proceed further. So since we know that sin square theta there is no integration, cos square theta there is no integration, and sin omega t cos omega t no integration. So these can be done by breaking the formula. Sin square theta can be written as 1 minus sin theta by 2, and 1 minus cos 2 theta by 2, and cos square theta is 1 plus cos 2 theta by 2, and sin theta cos theta can be converted as multiply and divided by 1, so that is half of sin 2 theta. Now this cos 2 theta, sin 2 theta and sin 2 theta, these can be get integrated. So once you do the integration between this limit, so we put the values and you will find out these parameters tend to be 0. So the values of this will become out to be approximately t by 2. This will be again t by 2, and this will be 0. So that means out of 6 parameters, 3 parameters you will get the 0 answer. So average kinetic energy loss will be equal to that will be equal to that we can able to find it out, 1 by 2 m a naught square e raised to minus 2 gamma t, and then first part was that is gamma square by 2 plus omega square by 2, or I can write it as 1 by 4 m a naught e raised to minus 2 gamma t into gamma square plus omega square. So this equation you got it now, but we know that from the beginning of the derivation that omega is equal to omega naught square minus gamma square, or squaring both sides we can get omega square is equal to omega naught square minus gamma square, or omega square plus gamma square is equal to omega naught square. So all these values you will get it out. So that means gamma square plus omega square can be put it as equal to omega naught square into e raised to minus 2 gamma t. So that is the average energy, kinetic energy loss, which you can able to find it out. Now next part we can find it out, the potential energy. Potential energy we can able to measure is half k y square. So y we already know that y is equal to a naught e raised to minus gamma t sine of omega t plus phi. So that was this one. Now we can put this value half k a naught square e raised to minus 2 gamma t sine square of omega t plus phi. So that way you will get it out. Again, now we have to find out the average kinetic and average potential energy, which can able to find it out again, 1 by t 0 to t half k a naught square e raised to minus 2 gamma t into sine square omega t plus phi. So by solving this integration, you can able to solve it out. Again you got the value of sine square, so you can find it out. This will become out to be into t by 2. So that means half of a naught square into k e raised to minus 2 gamma t into sine square is t by 2, so you can get it answered. So 1 by 4 a naught square k e raised to minus 2 gamma t. Now okay, what is the value of k? So that you have to find it out. So we know what is the value of k. Omega naught is equal to always k by m. So scaling both sides, omega naught square is equal to k by m, or k is equal to m omega naught square. So that value you will get it out. Now put it here, so it will be 1 by 4 a naught square k m omega naught square e raised to power minus 2 gamma t. So that is your average potential energy. So that means we have find out average potential energy and average kinetic energy. So you can find out total energy loss will be equal to sum of these two. So that will be 1 by 4 m a naught square m omega naught square e raised to power minus 2 gamma t, again plus 1 by 4 m a square um, m a square omega naught square e raised to power minus 2 gamma t. So I think so this extra m has been added out. No. So it will be 1 by 4 plus 1 by 4 is 1 by 2 m a square omega naught square e raised to power minus 2 gamma t. So that is the average energy loss which has been find it out. So then we can find out the power. Power is equal to d by dt of E. Dissipating of power is equal to rate of d by dt of E. So by solving it, you will get 2 gamma of E. So this is the value. So that's what the value we have got it out, the average energy loss or average power loss. Now we are going to define very important part, that is called as a quality factor. Quality factor for damped oscillator. Quality factor is defined as it is sometimes measured in terms of the efficiency of oscillator. So it is basically it is an parameter called which represent the efficiency of a oscillator. If the quality is very high, so that means oscillator is very efficient. If the quality is poor, then the efficiency is very poor. So in terms of quality, called quality factor, or it is called as Q factor. So that means the Q factor represents the efficiency of the oscillator. So it is defined as 2 pi times the ratio of energy stored to the average power loss per cycle. Average power loss per cycle. So this is the formula for quality factor, that is called a Q factor. So 2 pi, this is E, power of E, power we can get it from here. So that is equal to 2 gamma of E into T. So E get cancelled, 2 get cancelled, so it will be pi upon gamma into T. So that's the value of this one. Or pi upon gamma is called as gamma upon T is called as theta, and that's theta. This is Q, this is theta. So this theta is logarithmic decrement. So that is logarithmic decrement. Now we know that T is equal to 2 pi by omega and gamma is equal to 1 by tau. So that means Q can be written as 1 by 2 omega tau. So omega is angular frequency, T is a time period. So when you type omega frequency is equal to 2 pi by T and it is 1 by T. So it is tau cancel. So it is a dimensionless quantity. So Q is a dimensionless quantity. Now, so this is a dimensionless quantity. So that's the value of Q which we can able to find it out. Now, this value of Q can also be written in another form, 1 by 2 omega naught tau, or is equal to omega naught upon 2 gamma. So that is the quality factor of this oscillator. So this was about the last part of the damped harmonic oscillator, that is the quality factor, logarithmic decrement, the average energy loss, and many more parameter. Now one more important question which has been left out is about the LCR circuit. How to find out the LCR circuit? Now we are going to give you the problem. For example, now I just give you problem, solve it out. This is an LCR circuit. This is the power supply. Now what you have to do is you have to find out the value of equation for this one. So I know the Q by C is the equation for it, and L into potential drop across the capacitor. This is potential drop across the inductor. So this is the potential drop across the resistance, which is equal to E naught sine of omega t. So now I can write all the form in the form of Q. I is equal to dq by dt. So that means Q by C plus L d2q by dt square and plus R into dq by dt is equal to E naught sine of omega t. Now what you have to got it, so it will be L d2q by dt square plus R dq by dt plus Q by C is equal to E naught sine of omega t. Now divide both side by L, dq by dt square plus R by L dq by dt plus Q by LC is equal to E naught by L sine of omega t. Now this is the one particular part of the equation. Let R by L is equal to 2 gamma and omega naught square is equal to 1 by LC. So this equation will be d2q by dt square plus 2 gamma dq by dt plus omega naught square q is equal to E naught sine omega t upon L. So this is the formulation of the equation for LCR circuit. Now you solve this equation and get the various parameters, right? Quality factor, efficiency, all this, and submit it by Monday. Okay, so that's all about this topic, that is a damped harmonic oscillator.